So we have this interesting problem for us. 100x raised to the power logarithm of x minus 2 plus x to the power of 2 minus logarithm of x minus 20 equals to 0. And we want to find the value of x. Find the value of x. Now, if you look closely, you will see that this expression, your logarithm of x minus 2, is very similar to 2 minus logarithm of x. That is, one is negative of the other. So we could rewrite this as 100x negative of 2 minus logarithm of x plus x raised to the power 2 minus logarithm of x minus 20 equals to 0. Okay, now to make it much more compact or simpler, we could say let me write that in yellow. We could say let um, 2 minus logarithm of x, let it represent another letter, let's say u. Then we have 100x raised to the power minus u plus x raised to the power u minus 20 equals to 0. Okay, then we could say this could be rewritten as 100 over x, 100 over x to the power of u. That is, if we want to remove this negative, we could take it to the denominator, plus u plus x to the power of u minus 20 equals to 0. We could also use another letter to represent x to the power of u. We could say let x to the power of u represent another letter, let's say y. Then the consequence of that is that we have 100 over y plus y minus 20 equals to 0. So we could multiply through. If you multiply through by y, we are going to have 100 plus y squared minus 20y equals to 0 times y is going to be 0. So which can be written, we could write this neatly as y squared minus 20y plus 100 equals to 0, writing it in the decreasing power of y. Okay, so if we look closely, we see that we can factorize. This is can be factorized. So if we try to factorize this, we have factors are minus 10 and minus 10y and minus 10y, obviously. Since minus 10y times minus 10y will give us positive 100, and addition of minus 10y minus 10y will give us minus 20y. So this becomes y squared minus 10y minus 10y plus 100 equals to 0. So if you factorize this, you see that y is common. If you pair them, you have y into bracket y minus 10, and here 10 is common, 10 into bracket y minus 10 equals to 0. So this eventually results into y minus 10, y minus 10 equals to 0. And if you further simplify this, we see that y minus 10 is 0 twice, right? Which gives us y to be equals to 10. Now, having gotten y to be 10, we go back to our assumption here. So from here, we could see that x raised to power u is now 10, meaning that our x raised to power u is now what? Is now 10. Okay? In order to get u, we could say take the logarithm of both sides. We could say take the logarithm of both sides. That is, the logarithm of x raised to power u is equals to the logarithm of 10. Let's assume we are taking the logarithm of both sides to base 10. Okay, then we'll have this can be written from rule of logarithm. We know that logarithm of a number to the same base is 1, and we also know that the logarithm of a number to another variable, let's say q, is the same as q logarithm of that number. So it means this um, one can be written as u logarithm of x to base 10 is equals to 1. Okay, this could be written as this. So from here, we could see that u is 1 over logarithm of x to base 10. Okay, so u is logarithm of x to u is 1 over logarithm of x to base 10. Or instead of going through this approach, you could also say um, from here, it implies that logarithm of x to base 10 is actually 1 over u. Okay, logarithm of x to base 10 is actually 1 over u. And if we go back to our um, first assumption, we have 2 minus logarithm of x equals to u. So what does that imply? So if u is equals to 2 minus logarithm of x, okay, from up here, we have 2 minus logarithm of x is exactly equals to u. So from there, we could see that we could replace logarithm of x with 1 over u, such that we now have u is equals to 2 minus 1 over 1 over u, assuming we are working, of course, this logarithm is still the same as saying logarithm to base 10. So we multiply through by u, we have u squared is equals to what? 2u minus 1, multiplying through by u. And if you tidy this up, you could write this as u squared minus 2u plus 1 is 0. And we could say that if you factorize this, we are going to have um, the factors are minus 1 twice. So from here, we'll see that u minus 1 is equals to what? Is equals to 0 twice. So which implies that u is actually equals to what? Equals to 1. Now, our target is to calculate x. Then we go back to this assumption. We have logarithm of x is actually what? Logarithm of x is inverse of u, 1 over u, assuming to base 10. Now we have gotten u to be 1. So what do we have? We have logarithm of x to base 10 is 1 over 1. Okay? And we remember the transformation of logarithm. We could have a number, logarithm of a number, let's say m to base n equals to q. Okay? Transformation from logarithmic form to indical form implies that this can be rewritten as m equals to n raised to power q. So we could do the same thing here, such that since this is equals to 1, we could have our answer as logarithm of x to base 10 is equals to 1 now becomes x to be equals to 10 to the power of 1, which implies that x is what? Is going to be 10. So meaning that from this expression that we have, the value of x is what has been gotten to be 10.